Hello friends, welcome to Engineering Funda family. In this video, I'll explain you beam efficiency and stray factor of antenna. To understand beam efficiency and stray factor of antenna, you need to understand radiation pattern of antenna. Here I'll be considering directional antennas radiation pattern. You can observe here we have directional antennas radiation pattern, and this radiation pattern that I have already explained in my earlier videos. See, with this radiation pattern, this is major lobe of antenna. With major lobe of antenna, we have major power radiation. With major lobe of antenna, we have major power radiation. And this power radiation is there in desired direction, right? So major lobe consists desired radiation of antenna. If you observe by black color, here these lobes are side lobe of antenna. So here we have side lobes by black color, right? See, these are also minor lobes, right? And this is not there in desired direction. This is unwanted lobe that you can say. If you observe this yellow color lobe, so that is back lobe of antenna. This is back lobe of antenna. And this is also undesired radiation of antenna that one can say. So major lobe that is there in desired direction, and side lobes and back lobe that is there in undesired direction, and combination of side lobes and back lobe that is also known as minor lobes of antenna. Combination of side lobes and back lobe that is also referred as minor lobes of antenna. So based on major lobe and minor lobe, one can understand beam efficiency and stray factor. Now to calculate beam efficiency and stray factor, there are few parameters that you need to understand. See, first parameter that you need to understand based on solid angle of major lobe. Let me note it down. Solid angle of major lobe is rho of capital M, and here we have minor lobes that is a combination of side lobes and back lobe. Let us say minor lobe solid angle is rho of small m. See, major lobe is having desired direction of radiation and minor lobes are unwanted lobes, right? It should be minimum with antenna. Here in total solid angle, that will be algebraic sum of solid angle of major lobe and solid angle of minor lobe. So total solid angle is rho of capital M plus rho of small m. Now based on solid angles, one can identify beam efficiency. Let me explain you how. See, beam efficiency of antenna, that is solid angle of major lobe divided by solid angle of total lobes, right? So that is rho m divided by rho a. That is how one can identify beam efficiency. Now if you want to calculate stray factor, then stray factor is deficiency of antenna, right? So here if you want to calculate deficiency means stray factor, then that will be solid angle of minor lobe, that is rho of small m divided by total solid angle, right? So beam efficiency and stray factor that one can calculate based on solid angle of major lobe and solid angle of minor lobe, right? Now as if you add beam efficiency and stray factor, then you will be getting unity over here. Let me explain you how. See, if you add E small m plus E capital M, then you will be getting unity only. Why? The reason is, if you observe, see, E of small m, that is rho of small m divided by rho a, and if you have E of capital M, then that will be rho of capital M divided by rho a, where rho a is rho m plus rho small m. So here that is getting cancelled and you will be getting 1. So beam efficiency plus stray factor, that is equals to unity over here, right? And one should know even, see, efficiency can be 1 only, right, at max. So if you have highest efficiency over here, then stray factor will be 0 over here. And usually we calculate that in terms of percentage. So as if you want to calculate that in terms of percentage, you just need to multiply it with 100. Now in next video, I'll explain you how to identify solid angle. And based on calculation of solid angle, you can understand how to identify beam efficiency and stray factor. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.